Off air. On air. Hi, everyone. My name is Mitch. This is Open Source Block Explorers Now, number 11. Griff Green is taking some well-deserved rest and relaxation, so you're stuck with me this week. The purpose of this call is everyone in the space is somewhat happy with Etherscan, but it'd be really nice to have open source alternatives to such a crucial piece of the infrastructure. And so we'll start off the call. We're a little light today. I think a few folks on vacation, but there's a quick 30-second intro. So my name is Mitch. I am the director of product for an initiative called ETH Prize, which focuses on alleviating pain points in the Ethereum ecosystem, helping developers and users use Ethereum to its fullest potential. And Andrew Steve, if you want to have a quick intro.
Sure. Andrew Carvino from a POA network. We are building an open source block explorer for all EVM chains. I would like to go over a few updates on this call, just talk about what we've done. It's a little bit of a lighter week as we get closer to our version 1 release.
All right, Jakub, you're up.
Hi, I'm Kuba. I'm a co-founder of Analyse. We try to solve a problem of transparency in philanthropy by recording both donation and social impact on a blockchain. And recently we started to work on our own fully open source explorer.
All right, let's get right cracking. So Andrew, see, you're first on the agenda if you would like to have an update.
Sure. So this week, we finished all our real-time events on the UI that we'll be featuring in our first release. And then we started adding token support to the UI, which is for ERC20 and ERC721 tokens. And the last big update we had this week was we started adding in extended API support for a lot of the dApps that are migrating to POA network, such as websockets for the endpoints, which make it easier for some of these dApps to receive all these event logs and so on and so forth. And we plan to provide a demo on the next call, so number 12 of the Open Source Block Explorers.
Very cool. And that'll be in a couple weeks now. Same time, same network. Cool.
Yes.
And moving right along, I think Jakub, if you want to talk a little bit about your project. I think this is your first time on the call. Is that correct?
Yeah, that's exactly my first time. So my goal was just to learn you guys because I heard that you're working on similar stuff. It's always better to work as a team with the spirit of a decentralized community. And as I mentioned, I work for a philanthropy sector. And our big promise for all of the customer is the transparency. So we can demonstrate that both donation and impact was correctly recorded and cannot be tampered with by public service providers, charities, or anyone who validate the goals. And we used to just redirect them to Etherscan as an external source of truth. But obviously, it's not a perfect solution, as it's like a centralized product. That was the first pain for us. But actually, the bigger one was the form that Etherscan is presenting their data. So it's more focused on transaction. And when a user, for example, is interested what was the dynamic of funds collected for a project, we can present him with, I don't know, 200 or 300 transactions, which is unmanageable. And it looks like a black magic. It's like, it's good for nerds, for geeks, but not for plain mainstream donors. So that's we wanted to solve both issues. And we try a slightly different approach for our Explorer. We do not want to call it like a block explorer. We want to call it rather a smart contract explorer, because we want to present the changes and updates of internal state of a contract. That's our main focus. We want to differentiate a bit. So currently, a few months ago, we released a prototype called Etheroscope. It's live. Feel free to check it out. And the full source code is available on GitHub if you are interested. What's underneath that?
Cool.
And
quick thing, I'm really putting you on the spot, but yeah, if you'd be comfortable doing a quick demo, that might be interesting because we have a little bit of time here.
I just need to probably somehow share my screen.
Yeah, Hangouts is weird. If you press on the Hangout And then there'll be a green box with a white arrow that says share screen that might pop up.
Okay, let's do that. We'll do that.
Hey, Mitch, can you add the links to the bottom as well? That way people can check it out.
Oh yeah, that's a good idea. Jakub, if you if you telegram me those links, we can add those to the
definitely
comments.
I will. Yeah, I'll probably posted it, but
Yeah, thanks, Andrew.
So let's the more the merrier. Okay, I'm not prepared for the demo, but let's give it a try. Let's see how stable it is. Okay, I met our solution. So that's the Etheroscope. And let's see the popular contracts. That were the contract that were recently seen. And let's, for example, check our contract. Okay, so the first step is to fetch the metadata of a contract and try to distill a numeric variable. Currently, in our donation contract, there's like a total variable that show what was the total number of funds accumulated. And then there is a history of our pilot project. So we started somehow in April, and every change and every update is a transaction and an update of a contract state. So the funds were collected, and then there is this drop on a line. It was like a validation period when actually the funds were paid out to a charity. So you can track the full history.
Cool. Just one quick comment. I want to say that it looks exactly like my crypto accounts over December as well.
I think that's a coincidence. Okay, and obviously we got some nice features for, okay, on a single day there's nothing to display. There's also something for a year. Obviously you got this navigation, like a standard features. You can draw a histogram, stuff like that. We wanted to invest a bit into UI, just to give you more possibilities to present the data that's inside the contract.
Is this stored in a database, or are you just pulling directly from?
Okay, so I'm going to explain what's happening underneath. So we have a helper database with index data, so that's why this is blazing fast. But obviously, if you try to look into a new contract, it will take a while because we got an attitude that we fetch data on demand. So we reindex data when there is a request for a contract. And that actually segues way into a more interesting question. Maybe I'll just, where is Hangouts? Okay. So what are the problems and challenges that we are facing now? For example, we can reindex the whole blockchain and get all of the state data. But obviously, there's a large volume of data, and we take a few weeks just to perform the whole operation. That's why we stick to the on-demand approach. But we also find a problem with the speed of data extraction from blockchains. Currently, we are piggybacking on parity node and use a standard RPC call with over a Web3 just to collect the data.
I think you're still sharing your screen if you want to turn that off.
Okay, I just want to, let me just check.
Cool.
Yeah, is it better? Thanks, Mitch. So yes, there is a problem with a huge volume of data that need to be reindexed. Obviously, we can invest a bit of time, spend a month, get buy a bigger database, but it's not the point for, let's say, community block explorer, because anyone who would like to spin their own explorer will need to get through this painful process of reindexing. So we, especially if you are using the RPC and the standard Web3 interface, it's extremely inefficient and very long process. That's why we focus on optimizing the process, and we created another, say, sub-project when we want to directly access the data from a low-level blockchain storage, which is LevelDB, which is the representation of a Merkle-Patricia trees. And we did a lot of research. Unfortunately, it wasn't easy because all of the data are about how the actual state is stored is a bit scattered. But we get to the point. The project is also open source. So currently, we are not using the RPC layer. we extract the data directly from the level DB, and that was the first point. Actually, it allows like a 20 times faster extraction, but also there are some improvements with optimizing, let's say, the following calls. So in our procedures that scrape the MicroPatricia tree, we got a little helping data structures that keep the visited node, and when we find a duplicate, so we are sure that this part of tree hasn't changed in the previous block, we use the old value. So that gives us another factor of improvement. And we are experimenting in different approach for this data structure, whether it's just storing a path or storing a set of visited node, or having some heuristics with the transactions, whether the contract was included in a transaction. So we are experimenting with that, and I will be really happy to give you a better view of that when we run our benchmarks, because we prepared a few contracts with a different density of transactions just to demonstrate how much of a improvement in terms of speed can you get by using this, let's say, optimization algorithm.
Cool.
I'm happy to show you in the future. And obviously, all of that is open source. It's a bit of mess because we haven't finished the project and we are just exploring the algorithm. But if you are curious how to directly access the MicroPatricia tree, just go to our GitHub and take a look.
Yeah, that's great work. And that's on Geth, correct? You level DB?
Yes. We're accessing the Geth.
And have you done any work on parity by any chance?
No, it's still open to us. For the first project, we're using this additional structure that kept transaction history. It was like a parity archive mode. It was very helpful, but still haven't played with the low-level parity state tree.
Great. Yeah, I'm definitely going to check that out. It's awesome.
Hi.
Hey, Thomas. You guys would you have an update for this call as well? Unless Jakub, do you have any more closing thoughts on your project for today's call?
No, if I would be able, I would really like to show you some benchmarks and prepare a better presentation, because the goal for today was to get to know you guys. So
yeah, the next call will be in a couple of weeks. So yeah, we'll be sure to do that. Cool. Yeah, very, very, very exciting stuff to see that. And yeah, Thomas, just any updates from your end?
Well, I really don't have much of an update. I did a GitHub or a Gitcoin bounty for an account, and I learned a lot about preparing a Gitcoin bounty. You should be very careful what you prepare for, but it was good because I got some useful information about my code stuff. But I joined a little bit late. Can I ask you, is it Jakub?
Yeah, that's me.
Yeah, I just joined when you were saying that you were reading directly from the database for Geth compared to RPC. And did I hear you say that there was a 20 times speed up?
Yeah.
And that's extracting what data exactly? Are you extracting?
Okay, so let me explain. So our test, obviously, we just started benchmarking, but it was like over 10,000 of blocks. We're asking for the same state variable.
And what state are you able to extract?
So from a contract, we are extracting a numeric state, integer, that was stored in a contract over 10,000 block. Obviously, there haven't been a change in every block, but there were like this number of queries.
Oh, I see. So you know that happens to be an integer in that contract?
Yes. So over WebRPC, I was asking for like a standard method, so for a standard public variable, and over direct storage, I was just asking for a certain state. That was.
So you just experiment with that extraction.
Yes.
Great. And was it very difficult? Was it documented at all?
No, it was really hard. So for this summer, we got an intern, which is a second-year student, and I was working close to him So the first biggest challenge was the extraction of documentation, how the actual data is encoded in the micropartition tree. What are the rules?
Yeah.
And we crack it, and then we implemented that.
Was that
scattered all over the places?
And I imagine the source code was probably the documentation. Geth.
No, hopefully we find in a few different places, not expectant, but how the memory and the state of EVM works. So yeah, there were some clues, but obviously it was a lot of research to be performed. Yeah, but after we went through this way, we are hoping to describe it for anyone who would like to walk this path in the future.
I would definitely read that if you wrote something about that.
Yeah, that's the goal, to finalize this internship. Yeah, it was nice journey.
Yeah, please be sure to share that with the group, and yeah, I definitely want to put that on blast once you have those documents ready. And yeah, please once again share with me some links to your GitHub repo and things like that, so I can I'll put that in the description of
sure.
YouTube video. Cool. Are there any other thoughts for this call? It's a little bit of a skeleton crew. All right. Well, with that, I think that I just recently saw with Consensus Ventures, they have something called a Tachyon Accelerator, and apparently they're still looking for open source applicants to this. So I'm going to do a little bit of digesting, and I want to probably put that on Twitter, and I'll put that in the Telegram group. That might be appropriate for some people in the group. It might not be. I need to digest it or not. I think there's at least one of their programs where I think they move you out to San Francisco for a couple months, which, if you're a little bit younger, that's usually a lot more tenable than if you're a little bit older. But it seems like, yeah, a very interesting thing. And I was talking to Kavita Gupta, who's helping run that with Consensus Ventures today. And so, yeah, just another possible funding source for the folks that are out there. Cool. And with that said, this was Open Source Block Explorers number 11. We'll be live in a couple weeks at the same time at 4 p.m. EDT, and hope to see you then.
Thank you, Mitch.
Nice meeting you guys.
Thank you, everyone.